Hey everyone! Today, I'm going to show you how you can create this beautiful fluid ink or smoke effect for your own projects. If this is your first time here, welcome. My name is Sohail Farooq. I'm a web developer, and on this channel, I share creative techniques, coding tricks, and cool effects that you might not find everywhere else. So if that sounds interesting to you, make sure to like this video, subscribe to the channel, and save this video for later. You never know when it might come in handy. All right, now let's get started and create this beautiful effect. First of all, I've prepared a simple landing page. There's nothing too important going on here, and you can design your own landing page however you like. But since I want this effect to stand out and be more visible, I've chosen a white background with black text. Here's our text. And this is the navbar component. We're not really going to work with it. I just added it to make the page look a bit more complete. All right, now let's move on and create our canvas element. Once we've created the canvas, we'll also create a ref for it, since we're going to use it later to render our effect inside the canvas. We'll also apply these styles to the entire body. And make the canvas background transparent. Now, let's create a following cursor for the mouse pointer, so it follows the cursor wherever we move it around the page. This doesn't really affect our main effect, so you can skip it if you want. It's just a nice little visual touch to make the overall experience look better. Now let's add the mouse cursor component to our app. Now, we need to build the core structure of our effect, the actual heart of it. So, let's create a file called shader.ts. Since I don't have much experience with WebGL and shaders myself, I searched for an open source project on GitHub and found a project with the structure and shaders needed to create the type of fluid effect we're going for. I'll leave the link in the description, so if you're interested in where the code I'm using comes from, you can check out the original source. Now, let's go through the shaders one by one, and I'll briefly explain what each of them does. First, we have the vertex shader. It prepares the coordinates and basic data that the other shaders will need. Next, we have the splat shader. This controls the size and intensity of the effect around the mouse position. This shader is responsible for advecting the fluid. In other words, it makes the color and movement of the fluid get carried and displaced through the simulation. Then we have the curl shader. It calculates how much the fluid tends to rotate at each point. The vorticity shader uses that information to enhance the swirling motion and make the fluid movement look more natural and dynamic. Next, we have the divergence shader. It checks how much the velocity field is diverging and generates the information needed for the pressure step. The pressure shader calculates the pressure inside the fluid, which helps make the movement more natural and stable. Then we have the gradient subtract shader. It corrects the velocity field so the fluid becomes incompressible, making it behave more like a real fluid. The clear shader is used to gradually fade or clear the texture over time. And finally, we have the display shader. This is one of the most important shaders when it comes to the final look. It takes all the information from the simulation and generates what you actually see on the screen. All right, so we've got all the building blocks for our shaders ready. Now it's time to put them together and actually build our fluid effect. Now, to implement the actual logic behind our effect, let's create a file called fluid.ts. This file is basically the main brain of our fluid simulation. It handles the logic that brings all of our shaders together and actually runs the simulation. First, let's import all the shaders we created earlier. Next, we'll define the types we need. This GL type is simply a shorthand for the WebGL type we're going to use throughout the file. Then we have the FBO, which represents a frame buffer object. This is basically where we store and work with data on the GPU. We also have FBO. In our fluid simulation, we use two frame buffers, one to read from and the other one to write the results into. This technique is really important because the GPU can't read from and modify the exact same texture at the same time. So, we swap between these two frame buffers during the simulation. Next, we have program set, which is a type we use to manage our different shader programs. Now, this configuration object is probably one of the most important parts when it comes to customizing our effect. It contains all the main settings that control how the effect looks and behaves on the screen, such as density, resolution, speed, intensity, dispersion, and more. And the great thing is that we can come back here later and adjust these values to customize the effect exactly the way we want. Now, we need three main functions to make our effect work. The first one is responsible for compiling our GLSL shaders. The second one creates an executable WebGL program from our shaders. And the third one is responsible for initializing the fluid simulation inside our canvas. Now, as I mentioned earlier, I don't have a deep understanding of WebGL and shader programming myself, so I'm going to use these functions from the same reference project, WebGL Fluid Simulation, that I mentioned earlier. Don't worry, I'll leave the original GitHub project in the description so you can check it out and use it as a reference. And if you want to understand exactly how these three functions work, you can also use AI to go through the code with you and explain each part step by step. All right, that's everything we need inside our fluid.ts file. Now let's go back to our app component and actually start and run the effect. And there we go. As you can see, our fluid effect is now running beautifully. And if you want to customize it based on your own preferences, just go back to the config section and adjust the settings we talked about earlier. You can experiment with the speed, intensity, density, dispersion, and other parameters until you get the exact look you want. And that's it. Our fluid effect is up and running. And that's it. We just built this really cool fluid effect from scratch and brought it to life with WebGL and shaders. I hope you enjoyed the video and, more importantly, learned something you can actually use in your own projects. If you like this kind of content, make sure to hit the like button and subscribe to the channel, because I've got a lot more creative web effects and interesting front-end projects coming your way. And if you end up using this effect in one of your projects, I'd love to see what you create with it. Thanks for watching, and I'll see you in the next one. Keep building.